In this video, we will learn how to analyze stream patterns to identify the type of pattern one is viewing. In order to do this, one must have an understanding of what causes these patterns to develop. Stream drainage patterns develop as a result of the underlying geologic structure, such as the resistance of material to erosion and the slope of a region. While obtaining all this information from a map may not be possible to make a determination of the pattern, a knowledge of how each pattern looks and a brief knowledge of how they come to exist can help identify different stream patterns. There are 7 common stream patterns you may stumble across while looking at maps of regions. The names of these patterns are dendritic, trellis, rectangular, radial, centripetal, annular, and parallel. Starting with the dendritic pattern first, we can see that the branches of each stream appear to look almost like the branches of a tree. This is caused by the underlying geology not having much influence on the stream pattern, which allows the water itself to control how the pattern is created. Knowing how this pattern is supposed to look, we can see in this image how the streams in this map look like the branches of a tree. Moving on to the trellis pattern, this pattern is created as a result of the surrounding landscape. They are located in areas where there are high mountains surrounding the valleys, which help to channelize the stream between the mountains. As a result of this, the streams coming off the hillsides will intersect the main stream at around a 90-degree angle. This can be seen in this image where we have a fairly straight stream with other streams intersecting them at 90 degrees. The next stream pattern is the rectangular pattern. Rectangular patterns develop in areas where the underlying geology consists of faults and joints, which direct the stream direction. The joints and faults are usually less resistant to erosion than the area that surrounds it, which results in streams which are very straight and bend at 90-degree angles, as seen in the image. The fourth stream pattern to be covered is the radial pattern. This stream pattern is commonly confused with the parallel drainage pattern, as the streams do appear to be parallel to one another. The key difference between these two patterns is that radial pattern has all streams originate from a central high point and flow outward, while parallel drainage will flow from a high point but will ultimately merge into one primary stream. Looking at the image, we can see that this is a radial pattern, as all the stream locations flow from a central high point, and the streams all flow off radially from that location. If this were a parallel pattern, we would see all the streams coming off this hill going to the same general location, which is not witnessed, as all the streams here go towards various central locations. Another way to determine if it is a radial pattern is to identify if the location is a volcano, as radial patterns will exist on the outside of a volcano. The fifth stream pattern is the centripetal pattern. This is another commonly confused stream pattern, as it looks similar to the radial pattern. Both the centripetal and the radial pattern originate from a high point, like the peak of a volcano. However, the difference between the two is that a radial pattern flows from the high point outward, while a centripetal flows from the high point inward. Looking at the image, we have a pictorial representation of the center of a volcano, where the rim of the volcano is the outer edge. Looking at the streams, we can see they all start at the top and flow towards the center. This is a centripetal pattern, which we can identify by the streams flowing from a high point inward toward the center of a basin. The sixth stream pattern is the annular pattern. An annular pattern is found near eroded domes or basins where the underlying geology has been exposed. The exposed rocks act as a guide for the streams, which create almost concentric rings of streams, which is a key identifier of an annular pattern. The image shown helps to represent how a theoretical annular pattern is formed. The final stream pattern to cover is the parallel pattern. These streams form in areas of steep slopes, which results in the streams all flowing in the same general direction. This stream pattern typically is indicative of an area with a major fault in the region, as the landscape has a folded look with the streams being found in the low spots between the folds. The image shown is an example of a parallel pattern, as the streams are all flowing in the same general direction and appear to start from the same high area of the map. We can tell this is not a radial pattern because each stream has the same flow direction, which a radial pattern does not have, as only a few of the streams would have the same direction as you circulated around the high point where the streams originated. In summary, in this video we have learned how to look at stream patterns to determine the type of stream pattern that is formed. Determining the type of stream you have is based on three items: the general shape of the streams, the location in which they are found, and the underlying geology. Please feel free to share your comments and questions with your instructor regarding the content of this video, as well as to receive further guidance on the concepts covered.